the final. Let me just say that even though 4101 5101 student attend the same lecture, but the exam will be slightly different. Slightly different. Let me first make this clear. 4101 students under function of random variable, they only need to prepare for one-to-one transformation. I'm going to say that again. In this class, we did two variables to two variables, one variable to one variable. For 4101 students, they only need to study for one variable to one variable transformation. So they shouldn't care about two variable to two variable transformation. But as for 5101 student, of course, they should be preparing for two variable to two variable transformation. I believe that is clear, right? Okay, so that is for the. But every other question is going to look similar, but not exactly the same. Okay, now I'm going to start with. I've already uploaded this practice, and let me say, I'm actually going to. This is the area. This is the areas actually that the final exam question is going to come from. Now, number one, in one of the questions, you're going to have moment generating function. I will advise that you actually review all the moment generating function for distributions that we've done in this class. If you take a look at question one here that is being displayed, you don't necessarily need to prove if you already understand the moment generating function. But let me just give you the moment generating function that are very, very crucial, okay, for discrete, okay, try to Bernoulli binomial Poisson geometric negative binomial. Okay, when you're talking about moment generating function for moment generating function. Okay, I'm talking about for the final now, final exam. Okay, now we need you to revisit the moment generating function for this distributions. Then in the continuous, okay, one exponential gamma chi squared normal. Okay, now when you take a look at, I remember then okay, so like I said, okay, for these are very crucial for this final. So if I were you, review the moment generating function of this, of this, of this, of geometric, of negative binomial. I think I just write out the one for continuous distribution. Okay, now you need, of course, in this exam, I'm actually going to allow two sheet, okay, where you can write the necessary. Now, I need you to take a look at this question now. Okay, let x1 and x2 be independent random variables, and let x1 and y, where y equal to x1 plus x2, have a chi-square distributions with R1 and R degrees of freedom, respectively. So here R1 is less than R. Show that x2 has a chi-square distribution with R minus R1 degrees of freedom. Please, I need you to pay attention to this. Now, you remember what we did in class. If you take a look at this guy, okay, that is a sum of random variables, right? And if that is a sum of random variable, each of these follow chi-squared. Of course, you know, based on what we've done, the moment generating function of the sum, is a product of the moment generating function of the component, the x1 and the x2. Now, you have been told that, if I have a y, the moment generating function for y is this one, my of t, okay? And when you look at the sum of the random variable, is a product of that, right? And the question here is asking you, show that x2 has a chi-square distribution with arrow minus r1. Okay. Now, if you take a look at this arrow here is r1 plus r2. So what is r1 plus r2 minus r1? That will basically r2. Does that make sense? Now, which means they want you to figure out the distribution for x2, which means you actually need to solve for the moment generating function for x2. From here now, it's going to be this. Do you see that? It's just going to be that. Because I want to get the moment generating function of x2. It's going to be the total divided by that. I got this guy now. Now, the very next thing I'm going to do, what is the moment generating function of y? Is this guy. Because I was told that I'm working with a chi-square distribution. And if you come in, do you see this? Chi-squared? Okay. Right now, I'm using V degree of freedom. They can tell you R degree of freedom. There's no problem. So I'm actually, and that was why I'm writing this guy here. How do I know y has R degree of freedom? Because they've told you here, x1 and y have a chi-square distribution with r1 and r degree of freedom respectively, which means the degree of freedom for y is r, the degree of freedom for x1 is r1. Does that make sense? Now, what I just need to do is I'm actually going to write the moment generating function of chi-square for r degree of freedom and the moment generating function for chi-square with r1 degree of freedom. Now, I just need to simplify here. Okay, simplify, since this and this are the same. If this guy go there, so I'm actually going to, so finally, okay, I'm going to have this guy here. And what does that mean? Whatever that you see, okay, whatever that you see here is the degree of freedom. So here now, the degree of freedom, okay, is R minus R1. Okay, the degree of freedom here is R. The degree of freedom here is R1. The degree of freedom here is V. So that's why you need to take note of that. So at the end of the day, I've succeeded in showing. So I'll just finally, what I'm going to write finally is that, that follow chi-square with what? S2 follow chi-square with R minus R1 degree of freedom. I'm done. Give me 1 second.